Hi there, welcome to your lesson on exponential functions or the graphing of exponential functions. Let's begin where we kind of discussed in class. Exponentials are basically where the exponent on a number is the thing that varies. So the exponent is the variable. That's called an exponential function. And we looked at 2 to some variable power, 2, and then you can see that value varies and you get different values. And as you vary the value of x, the result rises very quickly like that. That's called exponential growth. So exponential growth starts off slow, grows very, very quickly. Every exponential function will look like that. So let's take a look. Here we have on the worksheet you're taking notes on, we're going to look at first something called exponential growth. All right, so that's something that grows quickly. And the example again, 2 to the x or 3 to the x, those are both functions that will show a very quick growth. So let's begin filling in these tables. When x is -2, if you put -2 in there, you end up with 2 to the -2. 2 to the -2, using your rules of exponents, ends up being 1 over 2 squared, which is 1 over 4. All right, from the work we've done with logs, that should come quickly and naturally to you, hopefully. So please fill in the rest of this table, and then when you're ready, pause the video, and then when you're ready, start it again. You'll see the values up here. All right, when you put a -1 in there, you should get a half. When you put a 0 in there, anything to the power 0 is 1. When you put a 1 in there, 2. When you put a 2 in there, 4. So those are your values. Now take those points and plot them here. So for example, -2, 1/4. You'll go -2, 1/4. You'll put a point here. So plot all 5 of these and then connect them to make the curve. Pause the video. Okay, hopefully when you plotted it, you end up with a curve that looks like this, all right? It is showing exponential growth, right? And the last point, for example, is 2, 4. So 2, 4 is right here. Or a really key point is 0, 1. 0, 1. That is a really important point. I'm going to mark it on there. It's a key point on an exponential curve. That point there, the one where we have the intercept. 0, 1. Okay, so that point is really important. Make sure you remember 0, 1. Now let's try the same thing with 3 to the x. All right, so again, fill in this table. You're going to put a -2 in there first and see what you get. Fill this table. Pause the video now and check when you're ready. Right, here we go. So first one, I can't really see that number, but it's 1/9 because you put a -2 in there. It becomes 1 over 3 squared, which is 1/9. Then put a -1 in there, you get 1/3. Put a 0 in there. Again, anything to the 0 power is 1. Put a 1 in there, you get a 3. A 2 in there, you get a 9. Now take these points, plot them as well. Maybe do them in a different color so you can compare the two graphs. Pause the video. All right, hopefully you got a curve that looks like that. It rises more quickly and it approaches the x-axis, the asymptote, quickly as well. So there it goes. And 2, 9, for example. So 2, 9, it's up there. So it's rising more quickly. So the bigger this number here, the quicker the exponential growth is. Let's look at domain and range. Domain and range is the same for both of those. So the domain is all the x values. And this graph will continue forever in that direction. It continues forever in that direction. That means the domain is from x values from -infinity to +infinity. All the x values are covered by those graphs. The range is all the y values. Well, this graph, as you notice, it is approaching this axis. It's never going to get to the x-axis. It's forever going to approach it but never get there. But then it goes forever in the positive direction. So the y values that are covered by this function are from 0 all the way up to infinity. All right, from 0 all the way to infinity, but nothing below. Equation of the asymptote, as I mentioned a moment ago, there's an asymptote there. Every exponential has an asymptote, so those two will never reach the x-axis. There's the asymptote, and the asymptote is at y equals 0. Okay, now let's look at the next one. This is called exponential decay. All right, so there's ones that grow quickly, and there's ones that decay, or it means decrease quickly. All right, and they always look like this. Notice this one, same as before. The x is the exponent, but there's a negative there. All right, or a fraction there. So if you ever see one with a negative in the exponent or a fraction as that base, then that is going to be a decay situation. All right, so compare it again to here. Here we have whole numbers, no negatives in the exponent. Those will always be growth. and these kind will always be decay. And the reason for that, let's take a look. So this one, if you convert that, it can actually change into this, because you can have 2 to the negative 1, which becomes a half to the x power. All right, so that and that are interchangeable, and that's why on this side we have this one, and that one is interchangeable with this, because if you bring that 3 up, it becomes 3 to the negative 1, and then 3 to the negative x. So notice those two are interchangeable, and these two are interchangeable. That's just to highlight the fact again that anytime you see a fraction or the negative exponent, that's going to be exponential decay. All right, so let's do this first. Put negative 2. It's probably easier to put negative 2 into this function, not this one, so put negative 2 in here. A negative and a negative makes a positive, so you end up with 2 to the power 2, which is 4. All right, now fill in the rest of this table. Pause the video. Okay, hopefully you got 2 for that one. 1 for that one. Again, you have 2 to 0 power, always 1. A half for that one. If you put a 1 in there, it's a negative 1, which ends up being 1/2, and 1/4 for that one. Okay, let's do the same here. Fill in this table. Pause the video now. Okay, let's see. Hopefully you got 9 for that one. All right, so I'm plugging into here. Negative 2 in there. The negative and the negative make a positive, so it's 3 squared, 9. Next one is 3, 1, 1/3, and 1/9. All right, just make sure you understand that. Now we're going to plot both of those as we did before. So take a moment now to plot these points. Pause the video. And check. Here's what your curve should look like. So now at negative 2 we had 4. So a negative 2 on the x was 4. And then negative 1 was 2. And it kept getting smaller and smaller. This is why it's called exponential decay. It's decreasing. It still has that exponential idea going on where it decreases very quickly and then slowly, but it's decaying in this direction. All right, decreasing. So now plot this one as well in a different color. Pause the video. All right, and when you plot that one, just like the last one, this one is decaying, but decaying at a quicker rate here because it's a bigger base. And that's what it looks like. Great. Domain, the same as before. X values are negative infinity to infinity. Y values, the same as before. The y values, it never reaches 0. There's an asymptote, and it goes to infinity in the positive direction. So 0 to infinity are the y values. And the equation of the asymptote, the same as the last one, at y equals 0. Great. Now that you know that, it's important to recap transformations of functions at this point, because this is you're going to apply this to exponential curves. So here is where we're going to start with x squared. So x squared looks like this. This is on the back of your worksheet, by the way. X squared is your basic parabola. There it is. Now, if I do f of x plus 2, that transformation means I'm taking the function and I'm adding 2. So I'm adding 2 to the entire function. And anytime you have that kind of thing happening, this is a change affecting y, right? Because f of x is like your y. So you're increasing the y values by 2. So the whole function or the y values are being increased by 2. So that means it's going to look like this. This one is a vertical translation, up 2. All right? Now, if you take that and, oh, let's see, did I go this way or this way? Okay, so I went across this way, then we'll go down after. So this one now, we're taking the whole function and subtracting 3. So again, that's affecting the y values. It is a vertical translation, but this time the whole function, you subtract 3 from it, so it goes down 3 units down to here. Sorry about this little mess here. I had a little part I had to cover up, but anyway, there's the parabola right there. Okay, next one. Now, it's not the whole function being affected by translation, it's just the x value. See how just the x? Here it's the whole function minus 3, or the whole function plus 2, but now it's just the x value being affected. So that one is a horizontal translation, all right? So to rewrite that, we take our original parabola, x squared, and we replace the x with x plus 1. So there it is. And that kind of translation, if you remember, is horizontal. We see it affecting x, and when it's a positive one, we go negative 1. So the parabola moves 1 unit to the left. All right, and the last one here, same thing going on. We're changing the x value, not the y value, just the x. So we're going to substitute x minus 2, and there it is. X minus 2 has been substituted. That is a horizontal translation. Minus 2 means positive 2 units this direction. Now we're going to take each of these functions and do another transformation on them. So I see a negative here, negative, negative, negative. We're doing some kind of reflection. This negative affects the whole function, so it affects the y values, right? And when you take all your y values and make them negative, it's like saying I have all these y values, and now they're going to be down here because it's going to be negative. So it's a reflection over the x-axis. So this is going to take this one and reflect it over the x-axis. Looks like this, all right? So the negative, first notice, has been applied to both this and this. It's been applied to the x squared and a negative 2 because it's been applied to the entire function. So there's the function, and again, negative to the whole function means reflection over the x-axis, so there it is. Next one, negative applied to the whole function again. That is a reflection over the x-axis again. The y values are being made negative. So the function, this function, will be rewritten like this, negative x squared plus 3, because the negative was applied to the whole function. And that one means it's flipping over the x-axis as well. So there it is. When you take this one and flip it, it's going to look like this. All right, next, now the negative is applied to the x only. So now imagine all the x values over here are made the opposite or the negative of themselves. So now they jump across this way. So all these x values become these x values. So that is a reflection over the y-axis. Every time you see that, reflection over the y-axis, so it will look like this. So the negative is applied to the x only. So here is x plus 1, so now we have negative x plus 1. So just the x is changed, because that substitution has been made in the function. And then it's been flipped over the y-axis, so notice it ends up being over here. Now we have this function, same transformation or reflection is applied. X is made negative, that means a reflection over the y-axis. Rewrite the function first, that x becomes a negative x, and that negative x there tells us a reflection over the y-axis, so that has reflected this way. Great. Now that we've recapped the main transformations you should be familiar with, we're going to apply them to exponentials. So here is your basic exponential curve for 2 to the x. All right, remember that important point, 0, 1. Now we're going to do all these transformations. Let's see what they look like. So the first one, first of all, let's look at this one, x plus 2. So that is affecting the x values. That is a horizontal translation. Only the x values are being affected. It says plus 2, so we're going to go minus 2. So I took that key point. That's really important to use here. That 0, 1 is a key point, and I'm moving that point back 2 units. All right, so translating it 2 units. So there it is. It's now here. And then it's helpful to have a second point so you can draw kind of a good curve. And the best second point to use is figure out the y-intercept. So make the x 0. So see how I'm putting f of 0? That means x is being made 0, and when x is 0, it's 2 squared, and we have 4. So that means 0, 4 is a point. All right, so that will look like that. And the asymptote remains in the same place, y equals 0. Next one, negative 2 to the x power. Again, I'm going to find that key point, the intercept, f of 0, and put 0 in there for x. All right, and that becomes 1, but there's a negative, so negative 1. Now let's look at the graph. Remember, when you put a negative in front of the whole function, it's affecting the y values. It's being reflected over the x-axis. The y values are being made negative. So this curve, the original one, has flipped over like that. See how it's reflected? And now that point that used to be 0, 1 is here, 0, negative 1. And the asymptote is still in the same place, but this one is now here. It's been reflected. All right, next one, 2x minus 3. What's going on there? This minus 3 is not applied just to the x, it's applied to the whole function. That means the y values are changing. That means this is a vertical translation, all right? Down 3 units, down 3 units. So we start at 0, 1, that key point, and that one goes 1, 2, 3, down 3, ends up being at 0, negative 2. Now it's really important when you're graphing this to also notice the asymptote has moved, all right? Since we're doing a movement up and down, that asymptote, which used to be there, also has to move up and down, and it moves down the same number of units, the same translation. This was, asymptote was here, now it moved down 3 units, now it's at y equals negative 3. So the asymptote is there, the key point is there, allows you to draw the curve very well. Okay, next one, 2 to the negative x. Over here, the negative was applied to the whole function. Over here, the negative is applied just to the x. And now, think about that again. When just the x values are made negative, it's a reflection over the y-axis, right? So the x values, so it's flipped that way. So this one is flipped that way. So see how it just flipped, mirrored that way. The key point stays the same, 0, 1. The asymptote stays the same. Last one, this has 2 transformations. I see a -1 here, a +3 here. So -1 affects the x, +3 affects the y. Negative means it's going to move +1, and +3 here is going to move +3. So now take this original y equals 2 to the x, and it moves right 1 and up 3. So here's where we begin at 0, 1. It goes right 1 and up 3. 1, 2, 3. So that point ends up being 1, 4. And just like here, the asymptote also has to move. Since we're doing a vertical movement, the asymptote, which was here, has to move up as well, and it moves up 3 units as well. So there's the asymptote at y equals 3, and there's the curve. All right, really important you know how to do that. Homework assignment looks something like this. It's in the textbook, and practice that. Make sure you know what you're doing. What you're going to do in assignment basically is it gives you 1, and then it gives you g of x. So f of x is the one that's graphed. You're supposed to add the graph of g of x to the same graph and using the transformations you see. All right, you can do it.